Okay, we're talking about fluids, and we've already done a couple labs on it, so let's go ahead and polish up and make sure we know what we're interested in. Right now we're talking about forces, and really ultimately what we're trying to figure out is why do fluids move. Now, in order to do this, let's make sure we define a couple things. First of all, what is a fluid? A fluid is anything that flows and forms the shape of its container, either a gas or a liquid. Fits our definition of what a fluid is. So gases will flow and move and can do things for us. Liquids will flow and move and can do things for us. So therefore our fluids are both gases and liquids. Now if it's called a gas, it's called a pneumatic system. If it's liquid, it's called a hydraulic system. So anytime you hear hydraulics, that means you're dealing with liquids. Anytime you hear pneumatic, that means you're dealing with gas. This is going to be things like air guns, air nailers. This is going to be things like shock absorbers, squirt guns, stuff like this. This would be a paintball gun because it's going to use a gas to move it. So understand with that. Now, the key thing on why things move is related to pressure, and pressure is equal to force over area. Now the two units for force over area, again in the good old English system, this is one you're really probably familiar with, and it's pounds per inch squared, PSI, but we write it that way. LB abbreviates pounds, inch squared, inch with a squared factor. In the SI system, it's newtons per meter squared. Now there is one number you need to know with that, and that's normal atmospheric pressure, which is 14.7 pounds per inch squared. That's normal, everyday air pressure. Lower in Asheville, greater in Charleston. So it does depend on your height above the earth, but it doesn't change a whole bunch. But that is the reason your ears pop. Well, the reason fluids are going to move is they're going to go from areas of high pressure to areas of low pressure, and they will automatically do that. So if I have something like a car tire, like this, car tire, like that, and inside that car tire I have, say, 30 psi. Well, outside I have less than that, so what's going to happen if I get a little nail, sticks in the car tire, air's going to come rushing out. It's naturally going to do that. It's going to go always towards the lower pressure. Has to. Now, car tires bring up one other thing. A flat tire is not flat. There's another constant, that's absolute pressure. Absolute pressure is compared to space, or compared to a perfect vacuum where there's nothing. When you put a tire gauge on your car, what it's going to do is it's going to tell you the pounds per square inch in that tire above what is there all the time. So therefore to get absolute pressure, I'm simply going to take my measured pressure. I can use a gauge, I can use a barometer, I can use a manometer, and I'm going to add to it the normal atmospheric air pressure. So let's say your car has 25 psi in the tires. You're going to add 14.7 psi to that, and you're going to have 39.7 psi if compared to space. And again, the absolute pressure is compared to a zero baseline. In the real world, we can't encounter that very much. So that. Again, fluids can move and they can do stuff for us, and that's the reason fluids are kind of important. And you think about them, they are used. All your air tools that you use in a machine shop or an auto body shop are all running off air. Obviously, air brakes on the bus are pneumatic systems. Your car at your house, your normal household car you drive all the time, has hydraulic brake systems, shock absorbers on your car. So we use this a fair amount in our everyday world, and you're expecting to know it. We've already done one lab with it. We'll do another lab later that involves the same thing. You need to make sure you know all that stuff. Hope it helped.